All right, so we're going to look at question 19 off of the Unit 2 test. This was the question where I showed you this graph. It's a graph of a rational function, and you had to figure out what the equation would be along with all these other characteristics of this graph and this function. So let's start off with just reminding ourselves what the template is for a function like this. This is a version of the function y equals 1 over x, but it's been shifted. It's been shifted up and down by some amount and left and right by some amount. So the template that we use to kind of write this function that got shifted up, down, left, and right is that we're going to say it's y equals 1 over x minus h plus k, where h is the left and right shift. If it moves to the left, then actually we have a plus h, and if it moves to the right, we have a minus h right there. And then k is our up and down shift. So I'll say ud for up and down shift. So what we need to do first of all is figure out how much did this graph get moved left and right and how much up and down. And the way we do that is look at where the asymptotes are for this graph. In the traditional graph, y equals 1 over x, we talked about how it has an asymptote on the axis, right? The y-axis is an asymptote and the x-axis is an asymptote. Remember, an asymptote is that kind of, I think of it as like a force field line that the graph can get really close to, but it can't actually cross. So I look at this and I'm trying to decide, okay, what is that vertical line? What is that horizontal line that this graph is obviously getting really close to, but not actually crossing? And those would be the lines that form the asymptotes for the graph. So I look at this and I notice that it appears that there's an asymptote right here. That this line gets, or this graph gets really close to this line right here. And you can see actually in the way this graph looks now, because it's zoomed out a little bit, it looks like it's right on top of it. But really, there's a really small amount of space between this blue line that I drew, that's the asymptote, and the maroon or red line that is the graph. There's going to be a really small amount of space there. But this is the vertical asymptote. The horizontal asymptote looks like it comes through right in here. So let me go ahead and sketch that. I get my little ruler out. So I can draw a nice straight line, and it looks to me like that asymptote is going to be right there. And now I need to figure out, okay, well, what if this is shifted left, right, up, and down, how much is it shifted by? Because normally, if we look at this horizontal asymptote, that's normally at this x-axis right here, and we can kind of see that this got shifted up 3 from the x-axis up to there. This vertical asymptote is usually at the y-axis, so it got shifted over to the right by 1. So if I'm talking about the equations of those asymptotes, which is what this part down here of the question is asking about, this equation, the equation of this one right here, is going to be y equals 3, because it has all the points on it that are some x coordinate, comma, 3 for the y coordinate, right? It has 0, 3, and 1, 3, and 2, 3, and 3, 3, and so on. So that equation is called y equals 3. This equation right here is called x equals 1, because it's all the points that are 1, comma, some number for the y. 1, 0, 1, 1, 1, 2, 1, 3, and so on. So my vertical asymptote over here, I can say is the line x equals 1. My horizontal asymptote is the line y equals 3. Now then, what about, how does that information fit into the equation of the line? Well, my equation is going to say y equals 1 over, it's a right shift, so that's going to be a minus sign. So it's x minus 3, right? Because it's a right shift by 3. We've shifted that asymptote to the right. Oh, not by 3. So it's not x minus 3. It's x minus 1. Sorry, guys. It's going to be x minus 1 because we've moved that asymptote 1 unit to the right. it's moving up 3. This is where the 3 comes in. It's moving up 3. So the up, I forgot to write here. Up is a plus and down is a minus. So since we're moving up 3, we're going to add 3 to the end. So this is our equation, and we could only write that once we figured out what the asymptotes of our graph are. The horizontal asymptote shows up right here in the equation. The vertical asymptote shows up down here on the bottom. It's tricky because the sign gets flipped. So if this instance is a positive 1, it ends up being a minus 1 right here. If it had been a left shift, this would have been an x equals negative 1, but it would have shown up as plus 1 right there. That's maybe the tricky part about writing this equation. But now that we have the equation, we can do these other answers maybe a little bit easier. The domain of your function is, remember, that is what values of x are allowed. And when I say allowed, I mean, without breaking any of the rules of math. The key rule is we don't want to have a 0 on the bottom of this fraction right here. So I can see that if I put a 1 in right here, 1 minus 1 would give me 0 on the bottom. So x is not allowed to equal 1. I can also see that if I look at the asymptote, right? That's why this graph gets really close to this x equals 1 line without touching it. Is because we're not allowed to put exactly a 1 into the function. We can put a number that's really, really, really close to 1. That's why our graph can get really close to this x equals 1 line on both sides, on the side where it's less than 1 and on the side where it's greater than 1. We can get really close to that x equals 1 value, but we're not allowed to use exactly 1. So the domain is everything except 1, and I usually write that as x does not equal 1. Our range is what values will this function spit out. If I use all the possible values for x, what are the possible y's that it's going to spit out? And this one's probably easiest by looking at the graph. We can see that the only y value that it doesn't hit is the asymptote at y equals 3. So our range, which let me just kind of possible, range means possible values for y. And our range is going to be everything except 3. Because we have a horizontal asymptote at y equals 3, our graph never hits y equals 3. It can get really close. It can get infinitely close to y equals 3 from above it and from less than the 3, but it can never hit y equals 3. So we call that range y equals 3. Now to find the intercepts, find the x-intercept, we use y equal to 0, and to find the y-intercept, we use x equal to 0. So I usually think the x-intercept is easier, so let's start there by finding that. I'm going to take my original equation. I'm going to set x equal to 0 and figure out what y equals. So it says y will equal 1 over 0 minus 1 plus 3. And so that's 1 over negative 1 plus 3. Right? 0 minus 1 is negative 1. 1 divided by negative 1 is just negative 1. And negative 1 plus 3 is 2. So it has a y-intercept at 0, 2. When the x is equal to 0, the y gives me 2. And I can just check on the graph, is this crossing the y-axis? That's what y-intercept means. Is it crossing the y-axis at 0, 2? Yeah, that would be this point right here, 0, 2. That looks like it's where it's crossing the y-axis. To find the x-intercept, we're going to set the y part equal to 0. So up here I'll say 0 equals 1 over x minus 1 plus 3. I just took the y and I made it a 0 and left everything else the same. And now we're going to solve for x. So I'll say use y equals 0 and solve for x. So first thing I'm going to do is subtract 3 from both sides. That's negative 3. I'm going to put it negative 3 over 1. You'll see why in a second. Equals 1 over x minus 1. Then, since I have a fraction on the left side of the equals and a fraction on the right, I'm going to cross multiply. So it's going to be negative 3 times the quantity x minus 1. This is getting multiplied by that, equals 1 times 1. I'm going to run out of space. I'll just kind of come over here onto the graph to finish it. So next I'm going to distribute the negative 3 in. It's going to be negative 3x plus 3, because the negative 3 times the negative 1 is going to give me plus 3, equals the 1 that's still over on the right. That was just distributing the negative 3 in. Then I'm going to subtract 3 from both sides. Negative 3x equals negative 2. Then I'm going to divide both sides by negative 3. So x equals negative 2 divided by negative 3 is going to give me positive 2/3. So my x-intercept then is 2/3, comma 0. I used 0 for the y, and it gave me a value of 2/3 for the x when I did that. And I just check on my graph. Does it look like it's crossing the x-axis at 2/3, comma 0? So that would be 2/3, comma 0. Yeah, that does seem to be about right. That looks like about where we're crossing that x-axis. So there's my set of answers. Again, just to refresh, just to kind of remind you, we have to start by writing this equation, but in order to write this equation, we need to figure out where the asymptotes had shifted to, where they're normally on the x-axis and the y-axis. In this case, it shifted up 3, which is why we have a plus 3 right there, and it shifted to the right 1, so that's why we have a minus 1 right in that spot. And once we have our equation, then we can think about domain, range, x-intercepts, and y-intercepts.